Hi there, me again. This is week, I think, 2.5. I have 19 more days to raise about $10,000, it looks like. I'm feeling incredibly grateful to all of those of you who have donated to the experiment on experiment.com about are we seeing photons travel in time. Some wonderful and amazing comments from people, and I just wanted to go over a couple technical details and some feedback I've had from some physicists so that those out there who are not physicists, you might not want to hear this part, but you might. So here we go. First of all, there was someone said, so photons actually can't interfere with other photons. And that's right, photons can't interfere with other photons. My understanding is that photons can interfere with themselves. But the thing is, photons are bosonic particles, which means themselves has a definition that's kind of broad. So as long as a photon has the same energy/frequency, phase, and momentum, it's considered the same photon. And there's plenty of those in the double slit setup that I'm using. So I think that I'm not so concerned about that. Someone else said, I thought that was an interesting point. They said, well, maybe the effects that you see in the first minute for the average are not a different effect from the standard deviation effects, because in a Poisson distribution, the expected value and the variance, which is based on the standard deviation, are the same. And so maybe that's a single effect. But that made me think for a minute, and then I thought, oh, right, but one of the assumptions of a Poisson distribution is that each of the events are independent. And the whole point of showing that mean effect, the fact that the mean of the number of photons in the first minute seems to depend on the duration, the eventual duration of the on time of the light source of the experiment, or of the run. The whole point is that, in fact, they don't seem to be acting independently. So while most people normally model photons being detected in a system like this as a Poisson type of process, the data show that, in fact, it looks like it's not a Poisson type of process. So I don't think you can make guesses about the standard deviation based on the mean. So that's another interesting point. Someone else offered a different kind of photon detector that's probably better than the one that I'm planning on ordering. If you have any kind of equipment offers or anything like that, let me know. That would be great if it works with the system. And someone else was asking, won't you want to make sure that the physicists know that you're not counting any photons from the photomultiplier after that first minute? And the answer is no, that's a misunderstanding. I am counting photons that come through every 2.5 seconds. I'm counting all the way to the end of the experiment. If the experiment ends up being 3 minutes long because the random number generator has determined that it will be 3 minutes long, then I'm counting photons every 2.5 seconds all the way up to the 3 minutes. If the experiment is 2 minutes long, I'm counting photons every 2.5 seconds all the way up to 2 minutes. So counting photons, yes. Recording them, yes. Recording those counts and looking at the nadir of the interference pattern and always at the same location, yes, yes, yes. But the dependent variable is what is going on in the first minute of the experiment. So I'm only, like, literally in an Excel spreadsheet, I'm only averaging across the first 25 counts because that's what's in the first minute. And I'm ignoring the rest. But I have the rest, so I know that the experiment, in fact, did maintain the light source for the appropriate period of time. Everything was working during that time. Of course, you can do an experiment, which I plan to do in the extension, which is to ask, if I don't record photons during those future times, in other words, if I just do not ask the photomultiplier to tell me how many photons have been gathering in the last second at each of those 2.5 second time points, in the last 2.5 seconds, at each of those time points, then does that impact the effect? I think it might. But I'm not sure. And in fact, the transactional interpretation of quantum mechanics, which some of the proponents claim that there's no knowledge effects, would suggest that would make no difference unless there's a difference in absorption. Whereas the two-state vector formalism, I'm not sure what those folks would think. So that's, who knows. Anyway, it's an unusual experiment, I admit, and so those are my favorite anyway, as an empiricist. And the final thing I'll say is that a couple theory people have said to me, well, you might be causing a paradox in time with this experiment, and I would say, well, it's clearly not a paradox because I was able to do the experiment and I didn't explode and neither did the equipment. So It might be a paradox for theory, but I don't think for reality. So anyway, thanks. Please keep sending this information to your friends and supporting interesting science.